So what we're going to be looking at now is we're going to be talking about one-to-one functions, and this is the first inside of the set of lectures about one-to-one and onto functions. So let's take a look at one-to-one, and we're going to define what one-to-one is, and then we'll give some examples. And then in a later video, I'm going to show how to prove that a function is actually one-to-one. So the definition for one-to-one is that a function f is said to be one-to-one if and only if f of a equals f of b implies that a equals b for all a and b in the domain of f. A function is said to be injective if it is one-to-one. Now, here's the thing, it's not a very illustrative definition, and so consequently, I think the examples are going to help us to understand what it means to be one-to-one. But basically, the idea behind one-to-one is that if I take one element in the codomain, right, or the range, it'll map back to only one element in the domain. So basically, I'm going to start over here in the codomain, right, and I'll map backwards to one and only one element in the domain. So let's take a look at an example first of something that actually is in fact one-to-one. So we'll take a look at the function f that'll go from r onto r, and we'll define it by f of x equals 3x plus 1. Okay? Now, when I look at 3x plus 1, what I want to imagine, I've got over here, I've got my domain, and that's r. And over here I have in my codomain, this is also going to be r. Okay? So I will map, let's say for example, 1 we know is going to map to 3 times 1 plus 1, it'll map to 4. Okay? So that's good. It's a function. That's what we should expect to have happen. We know that 1 will only map to one other element. Now what we want to get is that, is it possible, like say we have an imaginary element a over here, that's going to then also map to 4? And the answer is no. No, there's no way to actually get that. We can in fact even check it. If I take 3x plus 1 and I set it equal to 4, okay, that's going to be 3x equals 3, and then x is simply going to equal 1, right? There's no other way to get anything else. And so consequently, this one, a, must equal 1. Okay, so in fact, theoretically, we can actually imagine that we can just get rid of that line. That's the only one that's going to map there. If I imagine also, let's say, for example, I take 5, okay? So I take 3x plus 1, and I set it equal to 5, then that's going to give me 3x equals 4, and so x is going to equal 4 over 5. Okay, so over here, it'll be 4 over 5, and that's the only thing that 5 maps back to. Okay, choose any number that you want. Pick 0. All right, we take 0. Yes, so we get 3x plus 1 equals 0. 3x equals negative 1. And so x equals negative 1/3. And so that's the only thing that, in fact, 0 maps back to. And so consequently, it turns out that this function f of x, is one-to-one. Every element in R in the range maps back to only one element in the domain. Now let's take a look at another example, and this example is going to be one where it's not in fact one-to-one. Okay? And so this example is going to be f of x. F, we're going to take this, it's going to go from R into R. Okay? And it'll be f of x equals x squared. Now what'll happen is so I've got R here as my domain, and then I have R over here as my codomain. Okay? We already know from an earlier lecture that in fact our entire range is only the positive values. Okay, so we'll only look at, or non-negative, so these are the non-negative numbers, that's my range. And let's imagine that let's say for example, I take the number 1. I know that, if the number's negative, it's not going to map back to anything over in the domain, so consequently I'll take 1. So x squared equals 1, right? And then I'm going to take the square root of x squared, and that's going to equal, but it's going to equal plus or minus the square root of 1, which is plus or minus 1. And so consequently, what I get is that 1 maps to 1, and 1 maps back to negative 1. And so consequently, automatically, because 1 maps back to two different elements, f of x squared is not one-to-one, because f of x equal to 1 maps back to 1 and negative 1. This means f is not one-to-one. And we can actually see that. Let's choose a different number. We'll choose, say, for example, again, we'll choose 4. Okay, and if I take x squared equals 4, so then I'm going to take the square root of x squared. That's going to equal plus or minus the square root of 4, which equals plus or minus 2. Okay, so here's 2, and here's negative 2. And there we go. That actually, 4 maps back to 2 and negative 2. That also indicates to us that it's not one-to-one. So consequently, what we get is hopefully we can get a clear sense of what it means to be one-to-one. If we have a function where we take an element in the codomain, okay, and we map it back to an element in the domain, and it maps back to only one element for every single element in the codomain, right? Every element, not just one, but all the elements in the codomain map back only to one element, or all the elements in the range map back to only one element in the domain, then what we have is a one-to-one function. On the other hand, if one of the elements in our range maps back to more than one element in the domain, then what we have is not a one-to-one function, okay? And if we have a one-to-one function, we say that that function is injective, all right? So in the first case, for our first example, 3x plus 1 is in fact injective, but f of x equals x squared is not. And that completes the lesson on one-to-one.